The camera slowly drifts through the darkness of space. Stars sparkle like distant lanterns scattered across a black canvas. In the vast emptiness, a faint, glowing band stretches across the sky, a band that has captured human imagination for centuries. This is the Milky Way, a galaxy so enormous, so mysterious, that even our brightest telescopes can barely comprehend its true scale. In this cosmic ocean, our solar system is but a tiny island, orbiting a common star surrounded by billions of others. Yet to understand our place in the universe, we must first explore the structure of the Milky Way, the galaxy we call home. The Milky Way is a spiral galaxy. Its name comes from the Greek word galaxias, meaning milky circle, inspired by the milky glow seen in the night sky. From Earth, it appears as a faint, luminous path of stars stretching from horizon to horizon. But this simple glow hides a complex, dynamic structure, a cosmic city of stars, gas, and dust spinning in silent harmony. A spiral galaxy has several key components. At its very center lies the galactic core, a dense, mysterious region that holds secrets we are only beginning to understand. Surrounding this core are the spiral arms, vast lanes of stars, gas, and cosmic dust, winding outward like the arms of a cosmic whirlpool. It is along these arms that most of the Milky Way's stars, nebulae, and potential planets are found. And beyond the arm stretches a vast, faint halo, containing older stars, globular clusters, and invisible dark matter that binds the galaxy together. From our vantage point on Earth, we sit within one of the spiral arms, the Orion Arm. Our Sun is an ordinary star, about 26,000 light-years from the galactic center, traveling around it at an astonishing speed of roughly 828,000 kilometers per hour. Yet despite this speed, a single orbit around the Milky Way takes 225 to 250 million years. This means that during the entire span of human civilization, our solar system has barely moved along its path. We are cosmic travelers, moving slowly but steadily through the galaxy's vast corridors. As we journey outward from the center, the spiral arms reveal their secrets. They are not solid structures, but regions where stars form in clusters, where massive clouds of gas collapse under gravity to ignite new suns. Nebulae, colorful, glowing clouds of gas and dust light up these regions, birthing new stars in a dazzling display. Among them are the Orion Nebula, a nursery for young stars, and the Carina Nebula, home to some of the galaxy's most massive and luminous stars. Within these spiral arms, stars exist in astonishing variety. Some shine quietly like our sun, giving warmth and light to surrounding planets. Others burn intensely, massive stars that live fast and die young in spectacular supernova explosions, scattering heavy elements across the galaxy. These elements will one day form new stars, planets, and possibly life itself. Yet, for all its beauty, the Milky Way is not merely a static structure. It is in constant motion. Stars orbit the galactic center at different speeds, weaving intricate patterns. Clouds of gas drift and collide, triggering waves of star formation. Occasionally, the galaxy interacts with its smaller neighbors like the Magellanic Clouds, sending ripples through its spiral arms and shaping its structure over billions of years. The Milky Way also contains a hidden component, dark matter. This invisible substance does not emit light or energy, yet its gravitational pull is crucial. Without dark matter, the galaxy would not hold together, its stars would scatter into the void. Scientists believe that dark matter forms a vast, invisible halo around the galaxy, cradling the spiral arms and keeping the Milky Way intact. Its presence is felt in the way stars move, their paths bending under unseen forces. As we explore further, the galactic core draws our attention. This dense region is home to some of the galaxy's oldest stars, packed tightly together in a sphere that glows with ancient light. But the true marvel lies at the very center, a supermassive black hole, a dark abyss millions of times more massive than the Sun, known as Sagittarius A*. Its gravity dominates the motion of nearby stars, yet it is invisible, a cosmic enigma whose presence is revealed only by the dance of stars around it. The spiral arms, however, are where life might flourish. Around countless stars, planets orbit in delicate balance, some within the habitable zone where conditions could allow water to exist in liquid form. Scientists have discovered thousands of exoplanets in our galaxy, worlds of incredible diversity. Some are gas giants, others rocky like Earth. Some orbit close to their stars, scorched by intense heat, while others drift far away, frozen in the darkness. Each discovery fuels our imagination. Could life exist beyond our tiny solar system? Could intelligent beings gaze at their night sky, pondering the same questions we do? Beyond stars and planets, the Milky Way is home to cosmic phenomena that challenge our understanding of physics. Pulsars, the remnants of collapsed stars, spin with incredible speed, emitting beams of radiation like cosmic lighthouses. Black holes, hidden and powerful, warp spacetime itself, reminding us of the limits of our knowledge. Even ordinary matter like cosmic dust and gas plays a role in shaping the galaxy, forming clouds that collapse to ignite new stars and create the building blocks for planets. From a distance, the Milky Way appears as a serene, glowing ribbon. But up close, it is a place of incredible energy, violence, and transformation. Stars are born, live, and die. Gas clouds collide, spiral arms twist, and black holes pull with unseen force. Every particle, every star, every planet is part of a complex dynamic system, a cosmic dance that has continued for billions of years. Our journey around the Milky Way is only beginning. From the Orion Arm, we will eventually venture toward the outer reaches of the galaxy, exploring its spiral arms, clusters, and hidden corners. We will witness the forces that shape stars and planets, uncover the mysteries of dark matter, and approach the enigmatic heart of the galaxy. Yet even as we explore, questions remain. How did the Milky Way form? What will happen to it in the distant future? Could other intelligent civilizations exist within its arms? These questions drive humanity's curiosity, pushing us to build telescopes, send spacecraft, and peer deeper into the cosmic ocean. And as we gaze at the Milky Way from Earth, we are reminded of our place in the universe. We are tiny, fragile, yet connected to a vast, ancient galaxy that stretches across 100,000 light-years. Each of us is made of the same elements forged in the hearts of stars, scattered across the galaxy in ancient supernova. In a very real sense, we are children of the Milky Way, travelers on a cosmic journey that began billions of years ago. The Milky Way is more than a collection of stars. It is a story of birth, death, and transformation. It is a testament to the power of gravity, the beauty of light, and the mystery of the universe. And as we continue our journey, moving closer to its core, we will encounter wonders that defy imagination, phenomena that challenge our understanding, and secrets that have remained hidden for eons. In the next part of our journey, we will approach the galactic core, a place of extreme gravity, ancient stars, and a supermassive black hole at its center. Here, the laws of physics are pushed to their limits, and the mysteries of the Milky Way are most profound. But for now, we pause in the spiral arms, surrounded by billions of stars, each one a sun to unknown worlds, each one a beacon in the cosmic night. Our journey has only just begun. The Milky Way stretches before us, vast and luminous, a home to billions of stars and untold mysteries. And as we prepare to venture into the heart of the galaxy, we carry with us the wonder, curiosity, and courage that define humanity's quest to understand the universe. The camera slowly zooms toward the heart of the Milky Way. What once appeared as a faint glow now reveals itself as a dense, swirling maelstrom of stars, gas, and dust. This is the galactic core, the beating heart of our galaxy, a region of wonder and danger, where gravity reigns supreme and the very fabric of space bends under invisible forces. At the center lies a dark secret. Invisible, yet overwhelmingly powerful, a supermassive black hole dominates this region, Sagittarius A*. It weighs more than 4 million times the mass of our Sun. Its presence is betrayed only by the frantic orbits of stars around it, moving in patterns that seem almost impossible to comprehend. These stars dance at breakneck speeds, some completing a single orbit in mere decades, a blink of an eye in cosmic time. The core of the Milky Way is a place of extremes. Stars are packed tightly, millions within a single cubic light-year. The gravitational pull is immense. Stray gas clouds spiral inward, torn apart by the black hole's force, emitting bursts of high-energy radiation that ripple across the galaxy. Every particle here is under constant tension, caught in a cosmic tug-of-war between creation and destruction. This region is also home to the ancient stars of the galaxy. Many are more than 10 billion years old, relics from a time when the Milky Way itself was young. These stars have witnessed cosmic events beyond imagination, supernova explosions, collisions of star clusters, and the slow, inevitable growth of the central black hole. In their light, astronomers read the story of the galaxy's past, tracing its formation and evolution over billions of years. Around Sagittarius A*, matter forms a swirling accretion disk, a luminous ring of gas and dust spiraling inward at incredible speeds. Friction and gravitational forces heat the material to millions of degrees, releasing powerful X-rays and radiation detectable across the galaxy. These violent processes are a reminder that while the black hole is invisible, its influence is undeniable. It shapes the orbits of stars, governs the flow of gas, and even affects star formation in the surrounding regions. Time itself behaves differently near the galactic core. According to Einstein's theory of relativity, the intense gravity of Sagittarius A* warps spacetime. A clock near the black hole would tick slower than one far away. Light bends as it passes close to this invisible giant, creating strange optical effects like cosmic funhouse mirrors. Space here is not a calm void. It is a living, dynamic arena where physics is pushed to its limits. But the core is not just a place of destruction. It is also a crucible for creation. Gas clouds collide under gravitational pressure, igniting new stars in brilliant bursts of light. Some of these stars are massive, burning so brightly that they live only a few million years before ending in cataclysmic supernova. These explosions scatter heavy elements, iron, oxygen, carbon, the building blocks of planets and life, back into the galaxy. In this sense, the galactic core is both a graveyard and a nursery, a paradox of death and rebirth. Astronomers study this region using powerful telescopes both on Earth and in space. Infrared and radio waves penetrate the thick clouds of dust, revealing hidden structures and the paths of stars near the black hole. They track individual stars, watching them whip around the invisible center in precise orbits, mapping the shape of gravity itself. Each observation confirms the existence of Sagittarius A*, yet many questions remain. How did it form? How does it grow? Could it ever awaken into a more active state, releasing immense energy that could ripple across the galaxy? The galactic core also hosts exotic objects that defy imagination. Pulsars, the remnants of exploded stars, spin with incredible regularity, emitting beams of radiation like cosmic lighthouses. Neutron stars, densest objects after black holes, pack more mass than the sun into a sphere barely 20 kilometers across. Their magnetic fields are trillions of times stronger than Earth's, and some pulse with energy that could destroy anything in proximity. These objects are rare but abundant in the galactic center, evidence of the extreme conditions that dominate this cosmic region. Despite its dangers, the core is a source of inspiration and mystery. Observing it makes us confront the limits of human understanding. Here, gravity is not just a force, it is a sculptor of matter and light. Here, time can stretch and contract. Here, the laws of physics are tested in ways impossible to recreate on Earth. Every discovery challenges our knowledge and fuels the desire to explore further. Beyond the supermassive black hole, the core is surrounded by a dense central bulge of stars, stretching thousands of light-years across. This bulge is packed with old red stars, moving in complex orbits, creating a gravitational environment unlike anywhere else in the galaxy. Interspersed among them are clusters of younger stars, recently formed from infalling gas clouds. The mixture of ages, movements, and densities makes the core a dynamic, living environment, constantly evolving over millions of years. Astronomers have also detected mysterious flares and bursts of energy from the center. Some may be caused by gas falling into the black hole. Others may be the remnants of collisions between stars or compact objects. These events are unpredictable, reminding us that even in a galaxy as well studied as ours, surprises await at every turn. One of the most fascinating aspects of the galactic core is its potential connection to other galaxies and the larger universe. Supermassive black holes exist at the centers of most galaxies, and their growth is linked to the evolution of their host galaxies. Studying Sagittarius A* may help us understand the formation of galaxies billions of light-years away, peering back into the early universe. In a sense, the Milky Way's heart is not just a local phenomenon, it is a window into cosmic history. Yet despite all we know, the black hole and the core remain largely mysterious. What lies beyond the event horizon of Sagittarius A*? Could it be a gateway to another region of space or even another universe? While science cannot answer this definitively, the questions themselves inspire awe. The unknown draws us closer, pushing telescopes, probes, and human imagination to explore further. Visualizing the core, one can imagine a chaotic dance. Stars swirling at dizzying speeds, gas clouds colliding in brilliant flashes, black holes pulling relentlessly, and radiation streaming through space. It is a place of incredible beauty and terror, a reminder that the universe is far stranger and more powerful than we can fully grasp. As we move outward from the very center, the forces of gravity gradually weaken and the spiral arms of the Milky Way begin to reappear. Here, stars are more spaced apart, nebulae glow softly in the dark, and planets orbit in relative calm. But the shadow of the core remains. Its gravity, its energy, and its history influence the galaxy as a whole, shaping the structure of spiral arms, guiding the formation of stars, and setting the stage for potential life across the Milky Way. For humanity, the galactic core is both a challenge and an opportunity. Sending spacecraft to this region is currently impossible due to immense distances and extreme radiation. Yet, studying it from afar allows us to test theories of physics, understand the life cycle of stars, and explore the mysteries of black holes. It is a laboratory like no other, open to our eyes but resistant to our touch, inviting curiosity and rewarding those who dare to look closely. As we prepare to leave the core behind, we reflect on its significance. It is not just the heart of the Milky Way, it is the engine that drives its evolution. It is a place where matter and energy interact in extreme ways, where stars are born and die, where gravity and time bend in ways unimaginable. And yet, from our distant vantage point, it glows quietly, a reminder of the vast forces shaping the galaxy we call home. The mysteries of the galactic core will continue to challenge scientists for decades to come. Observatories on Earth and in space will keep watching, mapping the orbits of stars, detecting bursts of radiation, and probing the invisible gravity of the supermassive black hole. And as technology advances, we may one day understand the deepest secrets hidden at the Milky Way's center. But for now, the core remains a place of awe, a region that embodies both the power and the beauty of the universe. It is a symbol of what lies beyond human reach yet invites our imagination. It is the ultimate frontier within our own galaxy, a place where every discovery leads to new questions and every answer deepens the mystery. Our journey around the Milky Way continues. Having glimpsed the power and danger at its heart, we now turn to the outer reaches, to the spiral arms where stars and planets offer hints of life and possibility. From the chaos of the core to the calm of distant stellar neighborhoods, the Milky Way is a galaxy of contrasts, a tapestry of creation and destruction, mystery and discovery. And as we leave the heart of the Milky Way behind, we carry with us the knowledge that this galaxy, our home, is far more complex and wondrous than we ever imagined. The core may be hidden from direct view, but its influence stretches across 100,000 light-years, shaping the destinies of stars, planets, and perhaps even life itself. The journey is far from over. Ahead lie countless stars, unknown worlds, and the tantalizing possibility that somewhere, in the vast spiral arms of the Milky Way, life may be flourishing, watching the night sky, and wondering about us in return beyond the chaotic heart of the Milky Way. The spiral arms stretch outward like vast, luminous rivers, weaving the galaxy together. Here stars drift in quieter neighborhoods, glowing steadily, some young and fiery, others old and red, aging gracefully as they orbit the galactic center. It is in these regions, amidst the serene beauty of starlight and cosmic dust, that the possibility of life begins to emerge. Stars, the engines of the universe, are far from uniform. Some are massive giants, burning millions of times brighter than our sun, their lives short and spectacular. They live fast, burn intensely, and die in brilliant supernova explosions, scattering heavy elements into the surrounding space. Others, like our sun, are moderate and stable, providing a gentle warmth that allows planets to form and possibly sustain life. And then there are the faint red dwarfs, small and long-lived, quietly shining for trillions of years, their planets bathed in steady, persistent light. The formation of stars is an intricate cosmic ballet. Within the spiral arms, enormous clouds of gas and dust nebulae collapse under their own gravity. Regions of higher density form protostars, and as the gas compresses, the core temperature rises, eventually igniting nuclear fusion. In a flash, a new star is born, shedding light and energy into its surroundings. These stellar nurseries, like the famous Orion Nebula, are cradles of creation, where cosmic chaos gives birth to order and darkness transforms into brilliant light. Around many stars, planets begin to form. Dust and gas coalesce in spinning disks, gradually clumping into larger bodies. Some become rocky worlds, others gas giants, and occasionally, the right conditions allow a planet to maintain liquid water and a stable climate, the essential ingredients for life as we know it. Scientists call this the habitable zone, a region around a star where temperatures are just right, not too hot, not too cold, for life to potentially thrive. The search for these planets has accelerated in recent decades. Using advanced telescopes, astronomers have discovered thousands of exoplanets orbiting distant stars in our galaxy. They are astonishingly diverse. Some are enormous gas giants orbiting perilously close to their stars, scorched and uninhabitable. Others are rocky Earth-like planets, bathed in temperate light with possibilities that stir the imagination. Some planets orbit red dwarfs, receiving a faint but steady glow, while others circle binary stars, caught in a delicate dance of gravity. Among these discoveries are planets with extreme climates and conditions. There are water worlds, entirely covered by deep oceans, and ice worlds, frozen in eternal night. Some are tidally locked, one side perpetually facing their star, the other in freezing darkness. Yet in each case, the potential for life, as we do not yet understand it, cannot be dismissed. The Milky Way is full of surprises, and our assumptions about where life can exist are constantly challenged. The Milky Way is also alive with cosmic phenomena that could influence life. Supernova scatter elements across the galaxy, seeding planetary systems with carbon, oxygen, and iron, essential building blocks for life. Gamma-ray bursts, rare yet powerful, can sterilize regions of space, creating zones of danger. Magnetic fields protect planets from harmful radiation, while atmospheres regulate temperature and climate. Life is not guaranteed. It is fragile, delicately balanced amidst cosmic forces far beyond human control. Amidst these stars and planets, a question arises that has fascinated humanity for centuries. Are we alone? The search for life is not limited to distant planets. Within our own solar system, moons like Europa and Enceladus hide oceans beneath icy crusts, tantalizing hints that life may exist in unexpected places. Farther afield, the discovery of exoplanets' inhabitable zones raises the possibility that somewhere, in the spiral arms of the Milky Way, life has evolved independently, creating worlds as strange, diverse, and vibrant as the galaxy itself. Astronomers use every tool at their disposal to search for signs of life. Telescopes detect chemical signatures in planetary atmospheres, searching for gases like oxygen and methane that could indicate biological activity. Radio telescopes listen for signals from intelligent civilizations, scanning the stars for signs that we are not alone. Every discovery, every anomaly, fuels our imagination and drives our quest to understand our place in the cosmos. Among the mysteries of the galaxy are fast radio bursts, brief but intense pulses of energy originating from distant stars. Their origins are not fully understood, and while most are natural phenomena, some scientists speculate about the possibility of intelligent sources. These cosmic signals, fleeting and enigmatic, remind us that the universe is alive with phenomena we do not yet comprehend. They beckon us to explore, to question, and to dream. The spiral arms of the Milky Way are not static. Stars drift, clouds of gas collide, and clusters of young stars emerge in spectacular formations. Over millions of years, these arms shift and twist, shaping the environment in which planets and potential life evolve. The galaxy is not a silent backdrop, but a dynamic, ever-changing stage, where creation and destruction coexist in delicate balance. In the search for life, astronomers also study the chemical composition of stars. The presence of elements like carbon, nitrogen, and oxygen is crucial for life as we know it. Stars rich in these elements are more likely to host planets capable of supporting life. Observations reveal that the Milky Way contains vast regions with the right ingredients, hinting that life could be more common than we ever imagined. Yet the universe is also filled with uncertainty. Life requires not just elements, but stability, protection from radiation, and billions of years to evolve. Many planets may have the raw ingredients but lack the right conditions. Others may have faced catastrophic events that prevented life from flourishing. The delicate interplay of cosmic factors makes the emergence of life both miraculous and fragile. Beyond individual planets, scientists consider the possibility of advanced civilizations. If life has arisen elsewhere, could intelligent beings have developed technology, perhaps even observing our own solar system? The vast distances of the galaxy make communication difficult, yet the thought that we may share the Milky Way with other conscious minds inspires both awe and humility. Every new exoplanet discovered, every star studied, carries the tantalizing potential for companions in the cosmic journey. The Milky Way, with its billions of stars and planets, is a galaxy of potential. It is a place where the forces of nature combine to create worlds, where chemical elements come together in the dance of life, and where the unknown stretches endlessly. Each star we observe, each planet we discover, is a testament to the richness and diversity of our galaxy, and yet for all its wonders we remain explorers. Our telescopes reach only so far, our probes visit only a few worlds. The vast majority of the Milky Way remains unseen, filled with secrets waiting to be uncovered. Every discovery, from a distant exoplanet to a hidden nebula, reminds us of the scale of the galaxy and the smallness of our own place within it. As we journey through the spiral arms, we see the interplay of forces that shape life's potential. Stars are born and die, scattering elements across the galaxy. Planets form and orbit in delicate balance. Some worlds may harbor life, hidden beneath clouds or oceans. Others may be barren, reminders of the challenges of existence in the vastness of space. Yet the possibility persists. Life could exist in countless forms, in environments we cannot yet imagine. In the quiet regions between stars, we are reminded of our own fragility. Earth, a small blue dot in the cosmic ocean, orbits its star in perfect balance. We are fortunate to exist, to observe, and to wonder. And as we peer deeper into the Milky Way, we realize that the same forces that shaped our solar system may have shaped countless others, creating opportunities for life across the galaxy. The spiral arms stretch endlessly, their stars twinkling like distant beacons. Nebulae glow in brilliant colors, stellar nurseries hum with the birth of new suns, and planets orbit quietly, some holding the promise of life. The Milky Way is a galaxy of contrasts, violent and serene, ancient and young, known and mysterious. It is a galaxy alive with possibilities, a cosmic tapestry woven from matter, energy, and time. As our journey continues, we carry with us the knowledge that the galaxy is not empty. It is a place of potential where the seeds of life may have taken root countless times. And as we look to the stars, we are reminded of the ultimate question. If life exists elsewhere, will we ever find it? Or are we alone, the solitary observers of a galaxy filled with untold worlds and unspoken wonders? The Milky Way invites us to explore, to imagine, and to wonder. Its stars, planets, and cosmic phenomena are both a challenge and an inspiration. And as we prepare to venture toward the outer reaches of the galaxy, beyond the spiral arms and into the cosmic web, we carry the hope that somewhere life may thrive, waiting for discovery. Our journey is far from over. The galaxy stretches on, a boundless realm of stars, planets, and possibilities. From the chaos of the galactic core to the serene spiral arms, the Milky Way is alive, vibrant, and full of mystery. And somewhere hidden among the stars, life may be watching, waiting, and wondering just as we are as we leave the Milky Way behind. The galaxy slowly fades into a faint, luminous ribbon, its spiral arms stretching across the darkness like a river of light. From this vantage point, a new perspective emerges, one that is both humbling and exhilarating. Our galaxy, vast and magnificent as it is only one of billions in the universe, each a cosmic island drifting through the dark sea of space. The universe stretches beyond comprehension, a boundless expanse of galaxies, stars, and mysteries. Each galaxy contains billions, sometimes trillions of stars, bound together by gravity and dark matter. Some are spiral like the Milky Way, others elliptical, smooth and featureless, or irregular, chaotic in shape. Together they form the cosmic web, an intricate structure of filaments and clusters spanning unimaginable distances, where matter is woven into a tapestry that stretches across billions of light years. From this distance, our Milky Way seems small, almost fragile. Yet within it, countless stars shine and planets orbit in delicate balance. The scale is staggering. Light, traveling at 300,000 kilometers per second, takes 100,000 years to cross our galaxy. And even with all its billions of stars, the Milky Way is merely a single thread in the cosmic web, a single note in the symphony of the universe. Other galaxies are not silent companions. They collide, merge, and interact in cosmic dances that last millions or billions of years. Some collisions trigger bursts of star formation, lighting up galaxies with brilliant new stars. Others cause chaos, stripping galaxies of gas and reshaping their structures. The Milky Way itself will one day collide with its neighbor Andromeda in a slow, inevitable dance that will reshape both galaxies over the next 4 billion years. In the universe, nothing is static. Everything is in motion, driven by gravity, energy, and time itself. Amidst this grandeur, we begin to understand the scale of the universe. Galaxy clusters, collections of hundreds or thousands of galaxies, are bound together by gravity, forming immense structures that stretch millions of light years across. Beyond them, superclusters combine these clusters into even larger formations. And between these structures lies the vast emptiness of cosmic voids, regions almost entirely devoid of matter, emphasizing the immense scale and contrast of the universe. In these vast distances, light becomes both a messenger and a time machine. When we observe distant galaxies, we see them as they were millions or even billions of years ago. We are looking back in time, witnessing the history of the universe as it unfolded. Some galaxies we see today may no longer exist. They may have merged, exploded, or transformed in ways we cannot yet imagine. The universe is alive with stories, each galaxy a chapter in an epic cosmic narrative. Beyond galaxies, the universe is permeated by mysterious phenomena. Dark matter binds galaxies and clusters, invisible yet essential. Dark energy, a mysterious force, drives the accelerated expansion of the universe, stretching space itself. These invisible components make up more than 95% of the cosmos, leaving humanity to grapple with what we can see versus what remains hidden. The universe, in its vastness, constantly reminds us of both our curiosity and our limits. Humanity's exploration of the cosmos has begun in small, remarkable steps. Telescopes like the Hubble Space Telescope have captured breathtaking images of galaxies, nebulae, and distant stars, revealing the intricate beauty of the universe. Spacecraft have journeyed to the edges of our solar system, sending back data about planets, moons, and the sun. And ambitious plans aim to send humans to Mars, the moon, and beyond, extending our reach into the cosmos. Yet even with all our technology, the universe remains largely unexplored. Every new discovery raises more questions than answers. What lies beyond the observable universe? Are there other forms of life, perhaps civilizations that have evolved far beyond our understanding? Could advanced beings be observing us as we observe the stars? Questions stretch as far as the galaxies themselves, unbounded and infinite. The Milky Way, when seen in the context of the universe, teaches humility. We are part of a galaxy orbiting a common star on a tiny planet in a vast cosmos. Yet this perspective also inspires awe. Within this small, fragile planet, life has emerged, consciousness has evolved, and curiosity has driven us to peer beyond our world, to understand the nature of the universe itself. We are both insignificant and extraordinary, small in scale but vast in potential. Looking deeper, the cosmic web reveals patterns that hint at hidden order. Galaxies are not randomly scattered. They follow filaments of dark matter, clustering along invisible threads. Gravity sculpts the cosmos, shaping the distribution of matter over billions of years. And within these structures, stars, planets, and perhaps life find their places, obeying cosmic laws that are constant and yet mysterious. As we contemplate the universe, we are confronted with its age. Light from the most distant galaxies has traveled for over 13 billion years, carrying with it the story of the early cosmos. We see the birth of galaxies, the formation of the first stars, and the emergence of cosmic structures. We witness events that occurred long before our solar system existed, long before life on Earth began. The universe is not just vast in space, but vast in time, a history written in light across the darkness. Amidst this immensity, we return in thought to our galaxy. The Milky Way, spinning silently through space, is our home, yet also our gateway. By studying it, we understand not only the stars, planets, and phenomena within it, but also the processes that shape galaxies across the universe. It is a laboratory for learning, a window into the forces that govern the cosmos. In this exploration, humanity faces both challenges and opportunities. The distances are staggering, measured in light years rather than kilometers. Communication across the galaxy may take centuries or millennia. Yet with every telescope, every probe, and every observation, we inch closer to understanding our place in the universe. Knowledge expands not linearly but exponentially, revealing wonders we could never have imagined a century ago. And within this cosmic perspective, philosophical questions arise. What is the purpose of our existence in a universe so vast? Are we alone, or is life a common outcome across billions of stars and planets? The Milky Way may host countless civilizations, some young and emerging, others ancient and advanced. Perhaps somewhere, intelligent beings are looking up at their sky, asking the same questions we do. The thought is both humbling and inspiring, a reminder that curiosity, exploration, and wonder are universal traits, not confined to Earth alone. Our journey across the universe is far from over. Beyond the Milky Way lies a cosmos filled with galaxies, nebulae, and star clusters, each with its own stories, challenges, and possibilities. From the smallest exoplanet to the largest galaxy cluster, the universe is a place of beauty, mystery, and infinite exploration. And as we gaze into the cosmic night, we realize that this journey is not just about observation. It is about understanding, connection, and the quest to know where we belong in the grand scheme of existence. The Milky Way itself will one day merge with Andromeda, forming a new galaxy over billions of years. Stars will collide, planets may be scattered, and the structure of our home will change dramatically. Yet in this transformation, life and consciousness may endure, adapting, observing, and continuing the eternal quest to understand the cosmos. Change is inevitable, but curiosity persists. Even now, astronomers search for exoplanets beyond our galaxy, listening for hints of life and civilization. Projects like the Search for Extraterrestrial Intelligence SETI scan the stars for radio signals, looking for patterns that could indicate intelligent origin. Every discovery, every anomaly, every faint signal adds to the story of humanity's exploration of the universe, reminding us that the cosmos is not silent, only waiting to be understood. The universe stretches onward, beyond the reach of our telescopes, beyond the grasp of our imagination. Galaxies collide, stars are born and die, and planets form in intricate patterns that may host life. The Milky Way, our home, is both a cradle and a gateway, a galaxy of wonder that invites us to look farther, dream bigger, and explore more deeply. And as we leave the Milky Way in our cosmic gaze, we carry with us a sense of humility and awe. Our galaxy is but a single point in a vast universe, yet it is filled with life, energy, and potential. It reminds us of the fragility and beauty of existence, the power of curiosity, and the endless possibilities that await discovery. In the end, our journey around the Milky Way and beyond is not merely a quest for knowledge. It is a testament to humanity's desire to understand, to explore, and to connect with the universe that surrounds us. The stars, the galaxies, and the cosmic web all tell a story of creation, transformation, and wonder. And within that story we find our place, small yet significant, observers and participants in a universe that is infinite, mysterious, and breathtakingly beautiful. The universe beckons. It calls us to look beyond, to reach farther, to imagine what lies beyond the next galaxy, the next star, the next world. And as we continue our journey, we realize that the Milky Way is not the limit, but the beginning, a starting point for the endless adventure that is the exploration of the cosmos.